Hello, a warm welcome to all the students who are watching me online on my channel. Okay, let us start with and you can say continue the kinematics topic. That is point number 9. We can write acceleration as v into dv by dx, and just if you want to know how it came, then I can tell you. We know that acceleration, what is acceleration is equal to dv by dt. Okay, if we multiply and divide by dx, then this terms becomes velocity, and the whole becomes v into dv by dx. Very important. Okay, and our next point, that is point 10, 11 and point 12, are basically three equations of Newton's laws of motion. Okay, first is v is equal to u plus at, where u is initial velocity, v is final velocity, a is acceleration, and we will use this equation when acceleration is constant. Okay, and the 11th point is v square is equal to u square plus 2s, where s is displacement, and the 12th point, that is s is equal to ut plus half at square, and very important, velocity average is equal to average velocity is equal to u plus b by 2. Okay, and our 14th point, that is displacement of a particle in nth second. Very different thing. Nth second and t second are two different things. Nth second means we have to calculate that displacement that has happened in that particular nth second. Okay, that is and that is u plus a by 2 into 2n plus minus 1. Okay, where n is that second. Now very important topics comes, that is 15th, that is motion under gravity. We have to assume some assumptions, that is we have to consider sign convention. If upward is positive, then downward is negative, and rest applies all these three equation. Which equation? That is 10, 11 and 12. Okay, now now point number 16 is upward retardation. If a particle is moving upward, that is if we throw a particle in upward direction, then it is sure that we, in our daily life, when we throw a ball upward, we see that it retards. That means its acceleration is it is decelerating. Okay, in downward direction, acceleration opposite to the motion of the ball, that is deceleration. And that a net is equal to g plus a. Since we have assumed a net to be in negative direction, that is this, so we have to put negative sign here. And the time 2, and the time, and we can write time is equal to u by a plus g. How it came? When we how it came understood, we know that v is equal to u plus at. Since particle is going upward, so and a net is downward, so and our time comes at t when velocity of the particle becomes 0, so this becomes 0. Okay, 0 is equal to, what is u is upward, so we can write it as a positive sign. Since a net, we will write here a net. Okay, and by putting g plus a into t, so we get t is equal to u butta g plus a. Okay, so similarly, when we when we are going to explain downward acceleration, then a net comes a g by a, g minus a. Okay, just remember it. Now very important, projectile motion comes. When we think of projectile motion, then we have to assume that motion in xy plane. Okay, motion in 2 dimension. Okay, just focus that if we put a particle in upward direction, okay, and give it a velocity in horizontal, then that motion is called projectile motion. Okay, we have to analyze motion in x as well as y direction. Okay, for example, if we put a particle at origin and give it a velocity u, making an angle alpha with the horizontal x-axis, then we get if we take components of u in x and y direction, then we get ux as u cos alpha and uy as u sin alpha. And at a time comes when particle reaches to its maximum height, that height is called h, and it is maximum height. And when the displacement of the particle becomes 0, then we get range. Okay, that is when we had started this particle from origin, then we get same position, that is 0, that is displacement becomes 0. See it in y direction displacement. Okay, now 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 after assuming x and y direction, and and uh, and explaining the motion of particle in x and y direction both, we get time of flight equation, maximum height equation, and range equation, and that is 2u sine alpha by g. Very important, keep it in your mind. H is equal to u square sine square alpha by 2g, and r is equal to u square sine 2 alpha by g. And now when we do a projectile motion on inclined plane, so just assume that this is an inclined plane. Okay, and the inclination of the inclined plane is beta, and the particle is projected making an alpha angle with the horizontal, with the ground. Okay, and and for the sake of derivation of the formula, we have to make x and y axis. That is, if we take inclined plane as x axis, positive axis, and perpendicular to that is y axis, then we get alpha minus beta as projection angle. Okay, that is alpha minus beta. And acceleration in x direction will be and we know that acceleration is downward. See, okay, and as we take component of both acceleration in x and y direction, we get g cos beta and g sin beta. Okay, now assuming ax is equal to minus g sin beta, and we need not to assume that it is reality, and ay is equal to minus g cos beta. Acceleration and velocity in x direction, u cos alpha minus, same as that case, but we have put the same system in an inclined plane. So ux is equal to u cos alpha minus beta, and uy is equal to u sin alpha minus beta. Okay, and after solving this whole equation in x and y plane, x and y axis, we get time of flight is equal to 2u sin alpha minus beta by g cos beta. H is equal to u square sin square alpha minus beta by 2g, and range is equal to 2u square sin alpha minus beta by into cos alpha by g cos square beta. And very important, if you remember this formula, then this formula becomes easy, and it is the general formula. Okay, okay, when we put beta is equal to 0, then this case happens, that is when we put beta is equal to 0, then x-axis become horizontal. So after putting all this beta 0 in this equation, we get this. Okay, just remember this. A particle hits perpendicularly on into inclined plane. Just assume that when we have to derive the case when the particle hits the inclined perpendicularly, then what happens? Then we see that the velocity in x direction is 0. X direction velocity is 0. Then we need to analyze motion in x direction, and we put final velocity in x direction is equal to 0. Okay, so after solving these all types of equation, we get this relation 2 tan beta is equal to cot alpha minus beta. Important. And the second part, 21 part, is particle hits horizontally. That means after similarly solving this equation, we get cot alpha into tan beta is equal to 1 by 2. Very important, just remember this relation for horizontal hitting. Now very important, projectile projection from tower. In this case we will assume horizontally projection, theta angle with horizontal both up and down, that is theta angle from up, theta angle from down from horizontal. Okay, same sign convention, positive negative, theta angle up. Then we have then we will um, then we will get velocity in x direction, and that is component in x direction. We get velocity is equal to u cos theta, is equal to u sin theta, that is u cos theta, u sin theta. Okay, and acceleration in x direction is 0, as we see that x direction acceleration is 0, and acceleration in y direction is equal to minus g. Okay, and we similarly we can use these terms in these three formulas, uh, but in x direction and y direction. We will put this formula in x and y direction and derive equation for maximum height, range, horizon, and displacement of the particle, everything as we have discussed so far. Similarly, for theta downward, ux is equal to u cos theta and uy is equal to minus u sin theta, as the component of the velocity goes downward, so we write this as negative with negative sign. Okay, and acceleration in y direction in both cases is equal to minus g. We can use these three formula, and by putting these all values in this, we can find equations in different cases for calculating time of flight, horizontal range, and maximum height. Now from projection from horizontal, very simple, very important. It is used many times in many part of the topic. Okay, we will also use it in electrostatics, everywhere it is used, very important. Velocity in x direction is basically u, as it is only one, it has only x component, no y component. Acceleration in x direction 0, that is range is equal to u into t. Y motion, we get velocity in y direction is equal to 0, and acceleration in y direction is equal to minus g. So we get h is equal to half gt square. T is equal to root 2h by g, very important when we consider it as height of the body. And velocity in y direction, how we get this, do you know? By putting formula v square equal to u square plus 2gh. Okay, and similarly for range, what is range? When we multiply the velocity of the particle in horizontal direction with the time of flight, as understood, and that is the velocity in horizontal direction, that is time of flight, we get range. Very important formula, these three are very important, used everywhere almost, very important formula. Now relative concept, what is relative? What is relative? When we talk of relative, then we assume that a particle is in rest with respect to other particle. Everything in this world is has